All right, here we have a question about a guy, an entrepreneur, and his food cart business. We're told that any one of these food carts makes him $35 on average with a variance of 64. Now, we're told he also has 10 food carts, so bear that in mind. For the first part of this question, we're going to talk about the probability that he makes less than $30 with one food cart, and in the second part of the question, we're going to talk about what's the probability his average is less than $30. So let's just deal with the first case where one cart has less than $30. What we need to do is we need to use something called a Z-score. So what does a Z-score do? Well, a Z-score tells you how far a given value is from its mean. It tells you $35 or $30, whatever number we give it, doesn't really have a sense of magnitude. We don't know how big 30 is relative to what the mean is and how far that is from the mean based on the variance. So we convert a lot of our variables to Z-scores. Here we're given that the mean is 35 and the variance is 64, and we're asked how far is 30 from its mean. So let's use the formula for a Z-score here, x minus mu over standard deviation. We're asked, what's the probability that one food cart, not just the average, but any one food cart has a deviation, or rather deviates from its mean to as low as $30. So the revenue would be $30, that's our x value. The mean is 35, and the standard deviation, be careful here because this is a variance. So in order to get a standard deviation, you need to take the square root of that. Square root of 64 is 8. So the corresponding Z-score would be 30 minus 35, which is negative 5 over 8, or negative 0.625. Now, this is not a probability. Be very careful. I mean, obviously, it's not a probability because it's negative, but this is a Z-score. This tells you how far from the mean. It tells you it's in the negative direction. It tells you that the number $30 of revenue is below the mean, and by about 0.625 standard deviations. We then need to convert that to a probability. Now, how do we do that? There's a couple ways, but I want to first show you what the Z-score looks like on a normal distribution. So the normal distribution, or at least the normal Z distribution, Z is distributed normally with a mean of 0 and a standard deviation of 1. So 0 falls right there in the middle. A Z-score of negative 0.625 would be about here. And we're looking for the probability that the food cart revenue was less than that. So we're going to shade this area to the left. Our answer is this probability here, or our answer is this area here. The area here can be found in either a chart, so you might have a chart of z-values and you'll find the corresponding z-value that corresponds, or finding the z-value that corresponds to negative 0.625, and then look at the probability in that. Or you can also use a graphing calculator. A TI-84 is perfect for this technique. You can use the function normal CDF, and you can say, I want the lower bound here. When they ask you for a lower bound, it doesn't seem to have a lower bound, or at least it could go on toward negative infinity, right? This could go as far left as we want to. So we'll say negative 100. An upper bound of negative 0.625. You can put 0, 1 for mean and standard deviation, but that's usually the default. So normal CDF, negative 100, comma, negative 0.625, comma, 0, comma, 1. Like I said, that's the mean. And this is the standard deviation. We'll give you an exact probability. Now, for Dr. B's class, she doesn't care about that exact probability just yet. She just wants you to interpret this in terms of what's called the cumulative distribution function. What is the cumulative distribution function? Well, what the cumulative distribution function says, let me draw another bell curve here. It says that if you're given a bell curve like this, and you have a z-score here, whatever z-score that might be, the area to the left of this z-score is given by the function, we'll say area equals f sub, that's the word area, trust me, area equals f sub z of z. Or sometimes people just say f of z. That's a really confusing idea, but here's all that really matters for this problem. You find a z-score, and f will give you the area, which is, by the way, all we're looking for. We're looking for what is this area based on this z-score. You can use a table, or you can use your graphing calculator to actually figure out what that value is. We don't care for the purposes of this quiz. Or you can put it in terms of the function f sub z of negative 0.625. So this is our answer. Our answer is that this area will be f of negative 0.625. And whether there's a subscript of z there or not, it's not really relevant, but that is the probability that z takes on a value of less than negative 0.625, which corresponds to the probability that the revenue from the food cart takes on a value less than 30. The next part is a bit trickier. So the main distinction between part A and part B is that now we're being asked about the average revenue from the food carts. The average formula is a little bit different from this one. So we're going to give you a new formula. Let's do this in pink. the z-score that corresponds to an average is x bar. Notice the difference between x and x bar here. Minus mu over standard deviation over square root of n. Notice the square root of n here. So now we're talking about 10 food carts, right? Remember, we have 10 food carts at play, not just one, which is what we used here. Now that there are 10 food carts, now we have to recalculate the probability based on an average of less than $30 based on 10 food carts. So we're going to use same average, $30 was what we were asked about, minus 35 over 8 divided by square root of 10. And this number comes out to be, I think, about negative 1.97. Now, our z-score is a bit different. Before it was negative 0.625, and now it's negative 1.97. So we could draw a whole new bell curve if we wanted to, or and honestly, negative 1.97 would be here. Let's draw a new bell curve. Let's kind of put it here. Negative 1.97 falls a little closer to here. Notice it's a little bit further to the left of 0 than negative 0.625 was. And we're curious to know what the area left of that negative 1.79 is. Again, using the same function we learned from before, it would be f of negative 1.97, or f sub z if you use the subscript. You could, again, use a table, use a z-table to figure out what the exact probability is, or use normal CDF to figure out what that exact probability is. But for the purposes of this quiz, we're going to leave it in terms of the cumulative distribution function f sub z. The last part has us working backwards. Now we're told what the middle percentage is. We want to work backwards to find the sample size that would have given us such a middle percentage. So we're told that we want the middle 90% here, which means if they're symmetric around 35, we remember that the average was 35, right? So 33 and 37 are just as equally spaced around 35 above and below, which tells us that there's 5% here and there's 5% here. We can then convert whatever value corresponds to 0.05 area, again using a table, or this time using a function on your graphing calculator called inverse norm. Inverse norm takes in an area to the left of a certain z-score and tells you what that z-score is. So in this case, we want the area left to this particular vertical bar to be 0.05. So inverse norm will take in 0.05 with a mean of 0 and a standard deviation of 1, and will spit out negative 1.645. Now that I have this z-score, I can bring it over here using this value for x bar, this value for mu, and the square root of that value for standard deviation to figure out the value of square root of n, or in this case n. So let's take it from here. Let's say we found the z-score that corresponds to a 0.05 area on the left, and again this 0.05 exists because there's 0.9 in the middle, and therefore there must be equal amounts in the tail, or 0.05 in the left tail. So we have negative 1.645 equals x bar, in this particular case is 33, minus mu, which is 35, over standard deviation, which is still 8, over square root of n, which we don't know. Now, do a little bit of algebra. You can take the reciprocal of this guy. A lot of people think that this part can be a bit confusing. But remember, when you divide by a fraction, you flip the bottom fraction and multiply. So you can say negative 1.645 equals, this ends up being negative 2 over 8 times square root of n. We're going to multiply the 8 over, divide by negative 2, which tells us square root of n equals, let's see, we have 6.58, I think. And then we're going to square both sides to get my hands on n. N equals 43.30. Now this doesn't make any sense because n can't be a fraction of a number like this. N always has to be a whole number. We can't have 43.3 food carts. So when we get a number like this, when we're trying to find a minimum sample size, we always need to round the sample size up. So that means we have n equals 44, and that is our answer.